The first statement is false. All problems solvable in exponential time by a deterministic RAM take polynomial time on a non-deterministic RAM. This is not true. There are problems that would still take exponential time on both a deterministic RAM and a non-deterministic RAM. For example, if you wanted to find every sublist of a list, this is going to take exponential time, even on a non-deterministic RAM. The second statement is also false, because if randomized algorithms could solve some NP-complete problems, let's say vertex cover, in expected polynomial time, well, by the definition of NP-completeness, then we could reduce any other NP-complete problem to vertex cover and then solve that in expected polynomial time. And there's no evidence that this is actually the case. The final statement is true. If P is not equal to NP, then there are some NP-complete problems that don't have constant factor approximation algorithms that can run in polynomial time. The reason for this is actually the converse. We know that if we can find a constant factor approximation algorithm that runs in polynomial time for any NP-complete problem, then that implies that P is equal to NP.